Okay, so next talk will be by Tomáš Paník from SolarWinds, and it will be about AI agent sandboxing.
Thank you. Hello, everyone. I'm Tomáš Paník. I'm from SolarWinds, located in Brno. And in SolarWinds, I work. SolarWinds is observability company. We do observability products, and I work on observability of Kubernetes and observability of CI/CD pipelines. And also, I work in a project where we try to transition our AI SDLC from kind of AI-assisted workflow to AI native. So this is where my knowledge comes from. So this speech is about the sandboxing. Just 1 hour ago, there was some very interesting panel discussions about dangers of AI, and the panelists mentioned a lot of challenges. The truth is that companies will go after the velocity that comes with it. The YOLO mode, the famous dangerous they skip permissions in Cloud Code or auto approve mode. It's opening like a big velocity boost if you are able to run multiple agents in parallel using YOLO mode, and you have parallel sessions. Actually, right now, while having this talk, I run like 4 Cloud Code sessions on this laptop. The talk that is about how dangerous that is. Anyway, this year is the year of transition, where the companies are trying to transition to use this. As Boris Cherny said, the coding is solved. So this speech is not about the YOLO mode is not bad. I will try to explain how to use YOLO mode safely. So some facts: the coding agents are great in coding, also great in hacking, and unsecured by design. That's the fact. We want the first, but if you combine the second and third, you conclude that the coding agents will eventually try to hack us. And this was explained by one of my peers in some internal research, where he very easily tried to leave out of sandbox, and it took like 20 tokens. But that's like, it's the agents are not doing that on purpose. Then they are meaning it like they're trying to help. So now the sandboxes. Let's first talk about some attack surfaces and the real incidents that happened, so you can understand better how dangerous that is. In like 10 years ago or 20 years ago, it was the SQL injection, the thing. Today, like the AI agent is very similar, but it's more dangerous. It can be README, it can be GitHub issues, it can be PR command, whatever. It can contain this kind of instructions, which cannot be seen visibly, but the agent can read them and can ignore all previous instructions, read all the credentials, and send it somewhere. This was like real CVE that was fixed in Cloud Code, like in June, where it was proved that if Cloud Code reads this, he is able to send without any need for approval using the ping, the credentials using pings to some DNS addresses. So, and the ping is auto approve, was auto approve, is no longer there. It was fixed. Also, there was an incident where there's a very good blog post in this thing where the author is talking about the container, that the container is not a sandbox. That's true. The containers was designed for a totally different purpose, and it's very easy to to leave the container by agent. And he proved that if Cloud Code had a task and the sandbox was standing between the agent and the task, the Cloud Code quite easily left its native sandbox. It was not container; it was its native sandbox. But he found a way discovering some binary which he could use. He eventually disabled the sandbox and then continued on the task without the sandbox. So it's important to understand that there are multiple layers of the sandbox, and the containers is not the sandbox, and neither we will see in the future slide, neither the Cloud Code sandbox is not. There was a very interesting incident caused by Google anti-gravity. I will just paraphrase this because it's very interesting. A user asked AI coding assistant to clear a cache, turbo mode, auto execute was on. Agent run rmdir/s/q on D root instead of the project's subfolder, and entire D drive gone. Then the user asked the AI agent why he did that, and he was apologizing. We are observing very good throughput of apologizes. There were a couple of more incidents which I could mention. This one was highlighted in Hacker News, in April, and also in routine staging task. The user was doing some maintenance job, and agent decided to fix the job by deleting the whole volume, and the production database was gone in 9 seconds. Again, auto-approved, and again, agent was apologizing. I will not paraphrase this. Another incident, Replit agent, he deleted production database and faked the records and lied about the test results, again apologized. And the third which I found was the incident where the agent actually pinned in the project some vulnerable dependency, which actually contains some crypto miner. So agents, all the tests passed, it was fine, but the crypto miner was deployed. And we are seeing the consistency on the metrics, 0, 0. So in general, you can see that the threat is real. The incidents are happening. And there are I identified 6 attack surfaces. The prompt injection, it was already mentioned. The abuse of the tools, the agent has access to the tools. He can use whatever he wants. He can run the bash scripts. He can send curl credentials using curl somewhere. He can modify anything on the file system. This is extremely dangerous in terms of Git hooks, because even if you are in the sandbox and you have mounted volume, like the workspace, and he can put whatever he wants in the Git hooks, and whenever you run some Git commands on the host, then you're busted. And network, of course, he can post the data anywhere. And supply chain, I'm from SolarWinds. We all remember the Sunburst. We were attacked. Our supply chain was attacked, and this is where agent can do a lot of damage. For example, modifying npm post install scripts and so on. And the agent can also sometimes try to fix something that he wasn't asked to fix. But also one thing to mention, that even Anthropic documents in its documentation that there is the escape hatch. Is that if the Claude decides that, and he runs in sandbox, and he decides he should run some command outside of the sandbox, he can. He is allowed to dangerously disable sandbox and run whatever tool he wants. So that's documented. It's fine. It's the honesty, intellectual honesty. We should be honest in every tool like that. It's not criticism, but So now let's talk about the comparison of the tools we have to mitigate this. But first, I talked about Git hooks, but also dangers regarding mounting volume to the sandbox or in other places. The agent could modify the npm package JSON. So whenever you run the npm install on the host, you're busted potentially, and some other similar techniques. So I categorized the sandboxes into like tiers, and there are two categories of tiers. One category is how difficult it is to leave the sandbox. For the first tier is like no sandbox running YOLO mode, so no boundaries. There are sandboxes which are doing like syscall restrictions. This is like specifically for Mac or Linux, like Mac has seatbelt and Linux has bubble wrap. And for example, the Cloud Code sandbox is designed with this. And the containers, of course, tier 3, I put it in as tier 3. There's like special tier because there's like one tool gvisor, which is like hardening containers. So I put it like to extra tier, like a bit better container. And the last one is, hardware virtual machine or like micro VM. Those like the strongest sandbox we currently have. And the second category which I tiered is the network control mechanism, because some sandboxes has some network control mechanism, some don't. So we also have to categorize this. Like this is the same. First is none. The second, all or nothing. You can disable network or not. Then layer 3 or 4 boundaries. This is typical case of some kind of default Kubernetes network policies where you can disable by domain. Tier 4 is like stronger domainless restriction plus some proxy, where proxy could inject some credentials. I will explain that later. And the last layer is like layer 7 inspection, which means that the sandbox can inspect the HTTP packets and can filter, for example, the post and pass through the gets or something like that, which is extremely difficult to do, but some sandboxes can do that. I analyzed a couple of sandboxes, and this is where I ended up. I hope it is visible. There are some interesting ones. The containers I put in tier 3 of leaving the boundary, but usually they don't have network restrictions. We'll talk about that. But the only one which I put like into top right corner is OpenShell, which has the provider for using virtual machines. Actually, the Kubernetes ones I put like on layer 3 in the network, but it's actually not right because its default network policy is CNI, like Calico. It would be on 3, but if you use the Calico with Istio, for example, it would be on 5. If you use Cilium, it would be also on 5. So this depends on the CNI which you use in Kubernetes. So with Kubernetes, you could also reach quite easily the top right corner if you use Kata with Kubernetes and some good CNI. So now let's go a bit more into details of individual sandboxes. We have devContainers. Just raise the hand. Who of you have devcontainer JSON in your repo? Some hands. And keep hands up if you like denied some capabilities in the devcontainers. No one. I thought that. The devcontainers are not sandboxes, I said. It's not like it's quite easy. They share kernel. It's quite easy to leave the sandbox. But it's better than nothing, right? It's for sure. They were designed to be like consistent and reproducible environment, not for security reasons. But there are some things that you could do to harden it. First, you can drop the capabilities, because some of the capabilities are useful for agents to leave the sandbox. For example, By default, the agent can read the processes on the host, but if you disable the capabilities, he cannot. Of course, you can disable network, but it has some caveat. And you should also set him some user. But if you disable network, of course, you don't, you cripple the agent quite a lot. He cannot do npm installs, he cannot use MCP tools. So it would be unusable. But you could go around that if you configure IP tables on the host. In our company, we have some peers do that. We have some toolings for that it configures IP tables and do some proper better network limitations. But still, there are some better ways, right? The Docker currently released Docker Sandboxes, which does all of that for you. So let's now talk about that. Docker Sandboxes is currently in preview, so it's not released thing. It's used to be released with Docker Desktop, but now it's like separate. It's like special binary called SBX, and it's very easy to create this in the sandbox. They have some supported, let's say, agents where they pre-built images with those agents like Claude or Copilot CLI or Codex. But they also have like a shell template where you can put whatever you want. And you just SBS create a sandbox. And then, as you can see, there's some default network policies in place. By default, like most of the unknown things are disabled. They have some allowed list by default, but you can like configure it using SBS policy allow and quite easily configure where the agent could go and where it cannot. So I would recommend you to take a look at this. It's definitely better than containers for agent sandboxing. It's not container. What Docker claims is that it is micro VM. So each sandbox has its own kernel and has its could have its own Docker daemon. And they have some interesting proxying of credentials. And I have it on next slide. But this proxying is like there is only some allowed list of services which it can proxy this way. It works the way that there are no credentials in the sandbox, and for example, if you use Copilot CLI in the sandbox, it requires GitHub token, but in the sandbox you set some proxy managed GitHub token, and there is a proxy by this SBX which injects the credential to the request. So whatever the agent use, if it's GitHub CLI or if it's the MCP server or whatever, the sandbox proxy will inject the credential to underlying HTTP request which is sent. So the actual agent is never see the actual API token, so cannot like send it somewhere. So this is the architecture pattern which is used by several sandboxes. I mentioned it here, but OpenShell has this as well. In SBX, as I said, this is limited just to several vendors. It supports the GitHub, Anthropic, or some like there is list of tokens which it supports, but it cannot be like generalized to for your custom services. So those custom services and secrets, if you want the agent to use those custom services, it still needs to live in the sandbox, which is the advantage here. Okay, let's now talk about Cloud Code Sandbox on OpenShell. Cloud Code Sandbox can be quite easily enabled. There is just Sandbox enable through, and it has some proxy, so it has also some allow list where the network traffic is like disabled if you try to access somewhere else. There is also like restrictions on the file system, so it cannot then easily touch something But as I said, this could be like workable. He can go easily around that, but still better than nothing. So if you use Cloud Code, I recommend enabling that. This works only on Mac or Linux because they have this native syscalls restrictions in the file system. Windows doesn't, but usually the Windows users use this, WSSL version 2, which has that. So for Windows users, there is that WSL. There are some interesting facts I mentioned in the documentation. For example, this TLS traffic, until the Cloud Core doesn't inspect the HTTP request, which means that there is some threat like vulnerability to domain fronting that they mention it in documentation, which means that if the packet goes to github.com, but there is a special header called host, which like targets to some malicious website. The proxy doesn't see it because it doesn't inspect the request, but the CDN where it arrives will redirect the request there. So it's very vulnerability the vulnerability to this threat. And the read, edit, and write user permissions are handled using system restrictions, which is fine. Okay, now let's talk about OpenShell. OpenShell is a project which is in alpha stage. It runs also in developer workstations, so it is possible to run it on your own machines. It actually it has a Kubernetes plugin, but it's like experimental, and they claim it's like it can contain a lot of breaking changes. But the installation is very easy. You run like single command. You run OpenShell sandbox create to run the sandbox, and as I said, the OpenShell is able to. There's some special certificate. I don't know how they do it, but they inject certificate into the sandbox, and they are able to inspect the encrypted requests using that. So they are able to filter packets also based on a route where it goes, and also on the method. So you can, for example, restrict to some specific domain only post request. For example, if you decide to restrict all the pull request creation requests, you can do it using this policy. The policy is YAML. It's quite easy to read, and there's the approval. It works like that. Then there are some caveats, like that it's still alpha, experimental. But there are like 3 providers. One default one is that it runs on Docker. So if you have Docker desktop, you can install it and it will use that by default. And there is also like it can run on Kubernetes experimental. Okay, so I have detailed metrics where I put all this stuff into the table. I don't know if the interesting ones are those that has micro VMs, and interesting ones are those that are easy to use. I use Docker SBX. And some projects I use also containers because you have some tooling in the company on top of that. I'm following the OpenShell. And those other things I'm just following. And, Kubernetes, we have some plans with that, but it's out of my focus at this point. Okay, so I did some, let's say, guidance, what I recommend you to pick in some specific use cases. If you are like solo developer, have occasionally YOLO, like auto approved mode, Docker like sandboxes are like logical pick. If you like to have like more granular control or have requirements where you need to have network restrictions more granular, you can play with OpenShell. And of course, Kubernetes. Does anyone use Kubernetes to run agents? Very good. It's very easy. You can run agents like jobs. There is runtime class name, which gives you the escape boundary. In this case, it's kata, like the VM escape boundary, and the network policy gives you the control over network. So it's very easy to configure, and then you can run like the fleet of agents with whatever use case you want. And yeah, what happens if agent goes rogue? Like the 4 questions you should ask are this one. If the stakes are low, go with Cloud Code Native because it's easiest to install. You just enable it. For some local projects, use Docker SD, the Docker sandboxes, and for other cases, for enterprise or other projects, please use micro VMs or with some fine grained network policy. We speak with Docker a lot in SolarWinds. We are partnering with them, and one of the PM of Docker said that you should never run YOLO without a sandbox. Yeah, a lot of people accept the risk. I also accept the risk. That's fine. But you should be aware that there are those risks, and those risks are real. So just pick the tool from the metrics. Not it today. I'm not here to stop YOLO mode. I'm just here to put there some padding. And that's kind of my speech. So I'm still using YOLO, and I will. Any questions? Yeah, does SBX require Docker daemon? Actually not. They completely separated it. So SBX can be installed even without Docker desktop. And I have Mac, so you can just, if you have Mac, you just use Homebrew to install SBX, and you don't need to have Docker desktop installed. So it has some kind of its own like daemon separate from Docker desktop, so it doesn't need to be. There is now a Kubernetes stick agent sandbox. Did you have a chance to take a look on that? Not yet. Thank you for pointing this out. I will take a look. And some tools can filter out secrets. Can they as well filter P2? What is P2? Personal what?
Personal identify information like a EDR address, names.
No, I'm not aware of that. As I mentioned, the Docker sandboxes can inject secrets, but the OpenShell can do that as well. It's very much better configurable. In OpenShell, you can configure injecting headers to kind of any provider, not just those predefined ones. But I'm not aware that they could be like stripping out the secrets out of the HTTP request. I don't know. What about YOLO versus auto mode? Any hints on that? Well, you mean auto mode, this like mode which is auto approving all the questions and this kind of stuff, right? I'm not a fan of that. Of course, as I said, the YOLO mode is absolutely must in the enterprise these days. because if you run multiple sessions, you cannot auto like approving individual stuff, which is asking you would not be doing anything else than just approving. So the YOLO mode is must, the safe YOLO mode is must, but auto mode means that you are giving like more control, that he will be like answering the questions that agent would normally ask you, which I'm not fan of, and I'm not using that because when those questions are sometimes important when we are defining specifications with agents, letting agent define the specification and during the questioning, letting him also answer, kind of, you are losing the control over the whole process using that. So I'm not using this auto mode. Okay. Thank you very much.